Okay, so this video is on systems of nonlinear equations. Nonlinear means it's not a line. In the past few sections, we've been talking about hyperbolas, parabolas, ellipses, and so now we're going to talk about where they intersect if we have two of them on the same graph. On our screen here, we see an ellipse and a parabola. And just the different drawings. By the placement of the parabola compared to the ellipse, you could see that there could either be 4 solutions, 3 solutions, 2 solutions, 1 solution, or no solutions. I should say no real solutions. We'll talk about that in a little bit. But they can intersect at 4 points, 3 points, 2 points, 1 point, or they cannot intersect at all. That's really a better way of saying it. Okay, so we're going to be looking for where these graphs intersect. Now we could still have a linear function in the problem. Linear means a line. So it could have a line and a parabola, or a line and a circle, or a line and an ellipse, or a line and a hyperbola. So we're going to talk about those basic kinds of graphs. Okay? Now, one method of solving a system of equations is by graphing, but this is very impractical for finding intersections. It's really difficult to find out where they intersect if it's a fraction. Is that 2.5? Is that 2 2/3? So it does help us to understand the solution, where it is, but it's going to be better to do it algebraically. And so we've already learned these two methods. One of them is elimination, the elimination by addition method, or the substitution method. So we already know the methods that we're going to solve. We're not learning anything new. We're only learning it with new graphs. Okay, so then we have an issue of which method, substitution or elimination. Definitely elimination is easier, right? But we can only use elimination if all the exponents match. If all the exponents match. So if in the top row they're both squared, both variables are squared, and in the bottom row both variables are squared, then we could use elimination. If one of them has an x and y that's not squared, and the other one has both variables that are squared, then we will have to use substitution. Now, if one of the equation has a variable that's squared and one that's not squared, then usually you have a choice. You could probably use substitution or elimination. Okay, let's give it a shot. So here's our first problem. X squared plus y squared equals 10 and x plus y equals -2. On the top row, they're both squared. On the bottom row, neither are squared. So which method must we use here? Yes, we must use the substitution method. That means we have to get either x or y by itself. Then we need to decide which row we're going to use to get x or y by itself. Well, we definitely don't want to use the top row, because if we get x or y by itself, on the right hand side we're going to have a plus and minus square root, and that creates more problems. Okay, so we're going to use substitution, and let's get x by itself in the bottom row. You could get y by itself in the bottom row, but just so that our work matches, we'll get x by itself in the bottom row. So to get x by itself, subtract y on both sides. You could write that as -y minus 2 or -2 minus y, it will not matter. So now we're going to substitute that negative y minus 2, the right-hand side, into the first equation for x. Then we're going to solve for y. So negative y minus 2 replaces the x in the top row. So that's negative y minus 2 squared plus y squared equals 10. The negative y minus 2 squared, write that out twice, and then FOIL. Then you're going to add like terms, bring the 10 over to the left-hand side, factor, and you're going to get two solutions. So you might want to try to pause the video and work it out. Okay. So negative y minus 2 times another negative y minus 2, FOIL. Add like terms. Subtract the 10 on both sides. Now we need to factor. GCF is 2, so factor out a 2. Then factor that trinomial. The factors of 3 are 3 and 1. We wanted to subtract to be 2, so it'll be positive 3 and negative 1. Now we set all those equal to 0, so we get two answers, negative 3 and 1. Okay, hope that's going well. We got our y values. Now we got to plug it back into one of the original equations to find the x values that correspond with each of those y values. Now there's two rows. There's the top row and the bottom row. If you use the top row, when you plug in y, you're going to get two different x values that go along with it. But if you use the bottom row, you're only going to get one different x value that goes along with it. These solutions have to be solutions for both rows. So even though you could get a solution in the top row, you could get two solutions in the top row for x. They both will not work in the bottom row. So it gives us an answer that doesn't work in the bottom row. Therefore, you want to use the bottom row when you plug in these y values. So when you plug in an answer that you got into one of the original equations, if one of the equations does not have squares on the variables, use that equation. Okay, because it has to work in both rows. So we're going to use the bottom row. And we already have x by itself when we got x by itself, so we'll use that. So we're going to substitute negative 3 and 1 for y in the equation x equals negative y minus 2 to obtain the values for x. So plug in y equals negative 3 first. So there's already a negative sign, so it's negative 3 minus 2. Of course, negative 3 turns out to be a positive 3. And that gives you 1. Now plug in the other one. And that'll give you negative 3. So now we have our two solutions. So remember to put the x first. So it's x, y. So 1, negative 3, and negative 3, 1. Those are 2 points on a graph where the two graphs intersect. Okay, so we are all done. On the next slide, we're just going to look at the graphs of both of these. But basically, we're done here. Okay, so here's the graph of these two equations. Again, the solution is 1, negative 3, and negative 3, 1. The top row is a circle. The center is 0, 0. There's no h and k. And the radius is the square root of 10, which is about 3.1, 3.2. Do that on your calculator. Let's see, let me do that real quick. Square root of 10, and that gives me 3.16, right, 3.2. So it's got a radius of 3.2, so you go 3.2 up, down, left, right, and then draw your circle. So we can see that's a circle. And then the bottom row is an equation. If you get y by itself, you'll get y equals negative x minus 2. So it has a slope of negative 1. It hits the y axis at negative 2. Anyway, so we can just see that this graph is kind of reasonable, that our answers are reasonable to where the line and the circle intersect. Yeah, so again, as the circle has a center of 0, 0 with a radius of about 3.2. And so the graph does make sense. You don't have to graph it. As far as a check goes, you might want to check the answer algebraically to make sure your answers are correct. So if we check both of them, if you plug in the x and y into both equations, it should work out. And if it doesn't work out, then we know we made a mistake. And so here's a check for both of them. I'm plugging in the first point, 1, negative 3, into both top and bottom rows. That works out. And plugging in the second point, negative 3, 1, into both equations, and those work out. Okay, here's our next system of equations. Let's see, the top row has a minus sign in between the two variables that are squared. That means it's a hyperbola. When there's a minus sign in between, it's a hyperbola. It's not in standard form because there's a 4 on the right-hand side. So the top row is a hyperbola. The bottom row is another circle, so we have a circle and a hyperbola that are intersecting. All right, so let's see. We have two methods of solving these systems. One of them is substitution, and the other one is elimination. Elimination, I think everybody would agree, is the easiest. Can we use elimination here? We can, because all the exponents of each variable match. They're all squares. Right, so we could decide to either get rid of the x's or the y's. In this case, again, it won't matter. You could eliminate the y's or the x's just so that our work matches. Let's kind of be on the same page here. Let's eliminate the x's. So we're going to multiply the bottom row by negative 1 and then add the two rows together. Okay, so if we multiply the bottom row by negative 1, the top row stays the same, but the bottom row will be negative x squared minus y squared equals negative 9. Now we could add the two rows together, add the columns. So the x's, right, they'll cancel. And we'll end up with negative 5y squared equals negative 5. We're trying to get y by itself, so what's our next step? Yes, divide by negative 5. Then we're going to use the square root property to get y by itself. So that gives us y squared equals 1. So if you use the square root property, that's y equals plus and minus the square root of 1, and the square root of 1 is still 1. So that's why we get y equals plus and minus 1. Again, that is the square root property. Sometimes when you're watching a video or in class and a topic comes up like square root property, you might have to pause the video and then do a little research and go back. What the heck is a square root property? Anyways, we'll assume you know the square root property. So now we have to substitute 1 and negative 1 for y into either equation to find x. It will not matter which one you use here because all the exponents match. right? It's not like the last problem where the bottom row was only x plus y. So it won't match which one you use here. In both of them, we're going to get two values of y. I'm sorry, two values of x. Okay, so if we plug in y equals 1, that's x, we'll use the bottom row. X squared plus 1 squared equals 9. 1 squared is 1, so that gives you x squared equals 8. And then again, use the square root property. That gives you plus and minus 2 square root 2. Now what if we plug in negative 1 for y? Does it make any difference? No, it will not, because negative 1 squared is still positive 1, and then when you subtract 1 on both sides, you still get 8. So putting our answer together, we could have positive 2 square root 2 comma 1, negative 2 square root 2 comma 1, and the same thing goes on the right, positive 2 square root 2 comma negative 1, and negative 2 square root 2 comma negative 1. There's all four of our solutions. Here's the graph of both those. There are lots of different graphing apps or graphing programs if you don't have a graphing calculator. One of them is called Desmos. That's probably the easiest to remember, or the easiest to use, I should say. Desmos, D-E-S-M-O-S, Desmos. Another one is called Graphmatica, G-R-A-P-H-M-A-T-I-C-A. Probably Desmos is the most popular graphing program. I could be wrong, but it's very popular. Anyway, so we could see, remember we talked about that one of them was a hyperbola. That's the blue one that we have here, and the other one's a circle. Those are the 4 points of intersection. Okay, I'm not asking that you have to do that. Let's check our answers algebraically. I'm just going through, let's go back over that the hyperbola, it's not in standard form. So if you divide it by 4 on all of them, then it's x squared over 4 minus y squared over 1 equals 1. I didn't show it, but if you go back and watch the video on hyperbolas, you can plot your center and then go 2 left, 2 right, 1 up, 1 down to make our box, and then the asymptotes through the corners. And then because it starts out with the x squared, it opens left and right. Anyways, the second equation is a circle. Center is 0, 0. The radius is 3, so it makes sense. Okay, let's do another example. I didn't do a check on the last one. You could do a check, especially if it's a take-home test. You might want to definitely always do a check, make sure your answer is correct before you submit it. Okay, so let's see. Here's the first equation. What's our top equation? Y equals x squared plus 1. That is a parabola. And y equals x minus 1? Right, that's a line. So we're looking for where a line and a parabola intersect at. And keep in mind, they don't have to intersect, right? You can have a parabola and a line that do not intersect. Or they could intersect at 2 points if the line goes through the parabola. Or it could be tangent to the parabola and only intersect at 1 point. Tangent means that it just touches at 1 point and doesn't go through it. Okay, there's more to that whole tangent business, but we won't get into it. Okay, both the equations have a variable that's not squared. So we're going to use substitution. We actually could use elimination. There's actually a choice here because they do have a variable that does match exponents, and that's the y. So we could use elimination, but we're going to use substitution here. This is one of the kind of problems that you do have a choice. The first example that we did, no choice. You have to use substitution. The second equation we did, we used elimination because it's easiest, but we also could have used substitution. And this one we still have a choice, but we're going to use substitution. Okay. So since we already have y by itself in the bottom row, we're going to substitute the right-hand side into the top equation and then solve for x. So you see what we're doing there? So in the bottom row, it's y equals x minus 1. So you're taking that whole x minus 1 and plugging it into the x minus 1. You're plugging x minus 1 into y in the top row. Or, since you got y by itself in the top row, you could put x squared plus 1 in place of the y on the bottom row. You will still get the same equation. Okay, so now we have to solve this equation that we have on the right-hand side of our screen. Whenever you see an x squared, that means you have to get 0 on one side. So you're going to move over the x and the negative 1 to the right-hand side. So if you subtract x, it becomes a negative x on the right, and then if you add 1 to both sides, you're going to get a 2 on the right-hand side. Now we would try to factor that trinomial. Does it factor? It does not factor. So we still have to solve this equation. It doesn't factor. When it doesn't factor, then we resort to the quadratic formula. Quadratic formula, x equals negative b plus and minus the square root of b squared minus 4ac all over 2. 2a. Okay, so we're going to use our quadratic formula. Our a is 1, our b is negative 1, and our c is 2. So plug all those numbers into the quadratic formula, and then simplify. Whenever you get a negative number inside the radical, you take the negative out by inserting an I in front of the radical, and the number inside becomes positive. So you should get 1 plus and minus I square root 7 all over 2. I know, kind of ugly, right? That means it's a complex solution. So right now, that tells us that graphically, the parabola and the line do not intersect. But we still need to find the solution. And these solutions are still important. We have to know how to do them. There's lots of applications where we have complex solutions. Any engineering student will use complex numbers. Okay, so we're going to plug that x in, and we could use either the top row or the bottom row. I think it's probably easier to use the bottom row. Okay, so let's use the first one. X equals 1 plus I square root 7 over 2. We're going to use the bottom row, which is y equals x minus 1. And instead of x, you're going to replace the x with 1 plus I square root 7 over 2. Now we got to combine that. There's a minus 1 in the end. It needs to have the same denominator. So you're going to rewrite 1 as 2 over 2 because the denominator in the first fraction is 2. So 1 plus I square root 7 over 2 minus 2 over 2. Now we could combine the two fractions into one fraction. Negative 2 plus 1, that'll give you a negative 1. So we're adding the like terms. So that gives us a y value of negative 1 plus I square root 7. So that y value goes along with the x value, 1 plus I square root 7 over 2. A little confusing, but hang in there. I think you could do it. Now we're going to talk about our second solution for x. Again, we're going to do the same thing. We're going to plug that in for x in the bottom row again for x. So that's 1 minus I square root 7 over 2 minus 1. Same idea. We've got to write the 1 as 2 over 2, and now we can combine like terms. So that gives us negative 1 minus I square root 7 over 2. And so that new y value goes along with the x value that we just used. So those are our two answers. We'll write it in xy form. I know it is a little messy, but these are complex solutions. Okay, so we are done with the problem. Let's just look at the graphs on the next page. Here are the graphs. I graphed them on a computer program. I just put them on a graph and pasted it onto our page here. You can see that the top one is a parabola, and the bottom one is a line. And so we can see that obtaining a non-real number solution, in other words, a complex solution, means that the parabola and the line do not intersect in the real number plane. So they don't intersect.